Hello guys, welcome back to my channel. So today we are going to learn about object-oriented programming in Java. And believe me, this is not only related to Java, but it is a very important topic, and all the modern programming languages use this concept, like Python and all. So let's start our today's lecture. So consider a scenario where you are in the company, where a lot of other employees work too, obviously. So the job of the HR department is like whenever a new employee joins a company, they have to introduce that employee to each and every employee, and then they have so that like whenever that new joined employee want to ask or interact with some older like working employees like that are previously working in the company, they have to manually visit that employee and let them know like this is this employee's name and this is how they do and what they do, right? But the size of the company grows larger, so it is becoming difficult for the HR department to do this. It's like whenever a new employee joins, they have to introduce that employee to everyone. So now they ask you to create a system where you have to enter the details of all the employees in the same place, like in one place, so that whenever a new employee joins, they can visit that website or whatever the app is, and then they can visit like view all the details of all the employees, like what are their name, what they do, so that whenever they want to interact, it is easier for them to interact with. And they can also put their details so that all the other employees can know that this person is this, like what they do and what their name is. So you start programming. So you have to program a system where you have to enter all the details. So there is, suppose, employee one that is called Alex. So your employee, like the manager or whatever, they ask you to store the details like the employee ID, their name, and then what they do. And then there is a button, like whenever a person clicks on the employee button, like the employee icon, it says like, hi, my name is this, and then I work as this. So there is a functionality or method. This is called a functionality of this employee. So you have to create a system where you have to store the details and the methods, like the data and the methods of that employee. So for employee one, you store it like that. And then there is other employee that is named as John and they work as David. The problem is that there are like multiple thousands of employees in the company. So if you start creating like one by one, like details of all employees differently, like separately, then you have to do it like 1,000 times. You have to create 1,000 employees. But the problem is that, like in future, suppose the HR department or the manager ask you to add some more details about the employee, like what their age is, what their managerial level is, like what their level is in the company or something. So then you have to change this detail in all the 1,000 employees. So this task seems to be tedious. But one thing you can notice is that, like, because our manager wants to store all the similar sort of details and functionality in all of the employees. Like employee one is also having employee ID, employee name, and then designation. Employee two is having the similar data and the similar functionality as well. There is a get detail function, like whenever someone clicks on the employee icon, it will tell us that the employee's name is this and then what their designation is. So instead of like creating 1,000 times 1,000 details, we can create a template. And then from that template, we can use the template to create different employees by passing their information. So that whenever we have to make a change in this data or the functionality, we can just simply make change in that one blueprint or template, and then the details of all the employees will automatically get updated according to that template. So this template thing or the blueprint thing is called a class. So this is the concept of the class. So class is nothing but a template or a blueprint which we have to create for the set, like the set of objects or the category of objects, where we don't generally specifically mention the details and what functions are going to do, but instead we tell them like what features or what data we are going to store and then what functionality it is going to have. So so suppose you have to store all these details into one unit. So there is no data type that can store the different types of data. Like for employee ID, suppose we need integer value. For name, we need string. For the designation, we also need a string. And then there is also a function that is telling that what their name is and then what their designation is. So we have to create a custom sort of data type. And to create a custom sort of data type, this is sort of blueprint. And this blueprint is called a class. And from that class, where we don't define the details, like we just tell, okay, these are going to be the data and these are going to be method in this class, so that whenever an object, whenever we create an actual word entity from that class or blueprint, that thing is called the object. And objects are generally real word entities. So from this, we can understand, see like these two are objects. These are real world entities, like the objects Alex and the John are real world entities. That entities are derived from this class that is a blueprint. So that now if your employer or manager asks you to add one more detail, like the age of the employees, so you can just add one more string here just to change it, like just to change the details of all the employees, and then we can pass the data to create different 1,000 employees. We don't have to manually go to each employee and change their details, right? So this setup is called the object. This is the core concept of object-oriented program. That is, we do have classes that are blueprints, and then there is concept of object. Whenever we create like the real entities that are created from those blueprints are called objects, and then these blueprints are called classes, or we can say the templates we create are called classes. These are custom templates. Like we can have different sort of data, like different types of data and different methods, as many as we wish. So let's move further to see these things in action. Okay, so up till now we are working on the same class that is like Apple Java, but from now we are going to create a new class for this lecture, and then we will also learn how to like compile those classes into bytecode and then how to run those. So let's create a new class for this one. So let's say it's object-oriented programming system.java. Okay. So in this class, now first let's create our employee class, that is from which we are going to create multiple employees objects. Okay. So to create a class, we have to write this keyword that is class, and then we can give it a name, whatever name we want to give. This is a custom name. We can decide that add ourselves. Now in this class, we do have multiple data fields, and then there are some methods. So in the data fields, we do have employee ID. It should be of type integer, so we can give it a name as ID for now, and we are not going to declare the ID for now because we will do it later. And there is a field called string name. So that we can store the name of the employee. It is going to be empty string for now, and then there is also for designation. So we can say designation, and it is also going to be empty string for now. Beside these data fields, we do have some methods as well that are get details. For now, we can create a public, and because this method is not going to return anything, so we will say void, and then the method name is get details. So now here we are going to do that, like whenever someone clicks on the employee, it will say like, hi, my name is this, and then my designation or I work as this. So let's do that here. Oops. And it is going to say, oh, hi, my name is, or I am, whatever my name is, and then we can do this dot. You can see it is suggesting us, and after that we can say, and I work as, and then we can give their designation. Now you might be wondering, like, why am I using this keyword? Like, why am I typing this thing? So we'll learn in more detail, like we'll see this thing in action. But for now, let's go back to our PPT, and we can say like this keyword. Whenever we create an object of any class, like this is a class and this is an object, like the Alex is an object, like real world entity, and the John is real world entity. So whenever we create an object, and refer to that class, so this keyword tells us which object is referring to this class. So this keyword is used for that purpose. Like we will see this thing in action. So now our template or blueprint is created. That is, our class is created. Now let's create our objects from this class. So to create as we know, all the Java programs start from the main function. So let's create our main function. Public static void main, and it will have a string of arguments and these arguments. Okay, now inside of this, to create the object, we do have specific syntax that is like employee. Let's call this employee as emp1, and we'll say new employee. Okay, perfect. So now this is sort of like a syntax to create an object from a class. Now in this employee is the same as this class name. So whenever we are creating any variable or something, we have to tell what type of this variable is going to be. Like in this case, the ID variable is going to be integer type. The name variable is going to be string type. So in the similar way, like whenever we create object, so we have to tell the compiler like what type of object it is going to be like, or which class this object is going to belong, because there might be multiple classes in the same program, right? So we have to tell the compiler that what type of this object is going to be, or this object is going to belong to which class, right? So that's why we have to tell that compiler that this object is going to be employee type of class, like, or it is going to refer employee class, right? And now this new, and this is a custom name, like we have given it ourselves. We can say employee one, or even we can say Alex or something. Like, it is up to us, like what type of like the name of the object, whatever we decide. Now this new keyword is used to allocate a memory in the heap. Like whenever we create an object, so we need to allocate some memory in the heap memory, right? So this new keyword is used to allocate that memory in the heap memory. And this thing, you might be noticing that this looks very similar to some function, and exactly is sort of function. Like you can notice here as well, like whenever we create a method or a function, we put these set of parentheses, right? And in the similar way, we put it there as well. Like also you can notice in the main function, we do have this set of parentheses. So whenever we create a function, we put these parentheses. So this employee, like this one, is also like the method or function, but this is a special method that is called a constructor. So let's go and learn more about this constructor, like what this constructor do and how it works. So constructor is also a block of code which is used to instantiate a newly created object. What it does mean is that, like whenever we create an object, it is used to instantiate that object. So it is also a method, but it is used to instantiate that object, which normal methods don't do, right? And in comparison to that, like methods are just simply collection of a statement that sometimes do return some values, like, or maybe they might return void or something. So, and the other thing, the special thing about constructors are that like they are implicitly invoked. That means we don't have to like call them explicitly. They are implicitly invoked. Like whenever the method or the object is created, they will be called automatically. We don't have to explicitly call them. But the methods, we have to call them, right? Like they cannot be implicitly called like unless we are calling them. And the third different property of constructor is that like they don't have any return type. Like whenever we create a constructor, we don't have to, like we will create a custom constructor as well. Then we will see this point, like we'll understand this point better. But like all the methods, they do have some sort of like return type, whether it's a void or like whatever the data type, whatever it is. But they do have something, right? But constructors don't have any data type. And the final point is that like the name of the constructor is same as the class name. So in here as well, we can see like this employee name is same as the class name as well. So this is sort of like special method. We'll create our custom constructors as well. Like we'll get into more details. Now first, let's populate this our object, because right now we created the Alex object, but this Alex object don't have any ID or name or designation till now. So if we call this function on this object, like on the Alex object, it will say nothing because we don't have given it any name or something. So let's give it a name. So to give it a name, we have to like write the name of the object, and then we have to use this is called a dot notation to access the data fields, like these data fields to access. So now you can see like it is suggesting us what data fields we can access. So we can access the ID. So let's give the Alex ID of 01, let's say, and now we can also set the Alex name. Like we can say Alex.name, and then we can give whatever, like, okay, this is name Alex, so we'll give it a name as Alex or whatever name we want to give. And then we can also set its designation. So let's set its designation as a software developer. Now, if we call this get details function on this object Alex, then it will say, hi, my name is Alex, and then it will say like I work as software developer. Now let's call this thing. So to call the function as well, to access the data or to call the function, we have to use the same similar method. We have to use this dot notation on that object. So we can say like Alex.get details, and now if we save this program and run this, so let's save this. So hopefully we should be getting like, hi, my name is Alex and I work as a software developer. So to save this class or this program, you have to write this sort of syntax, like that is Java, and C is for compiler, and then we have to give the name of this class, that is oops.java. Now let's save it. Oh, one thing to notice is that like we can make this mistake again. So it says like file not found. Oh, oops.java. And why? Because we are like our terminal is in the test project folder, that is this one, like this directory, but our program or our class is inside the source folder. So now first let's move to our source folder, So these are like small mistakes we can encounter, and we should know how to fix these sources. So, oops, cd cr, sorry, my bad. src should be right. Now we are inside the source folder. We can see now we'll run the same command again. That is like java c oops.java, and this time hopefully it should create like the bytecode for these classes, like for oops classes and the employee class differently. So we do have two classes. Like this is one class, and this is the other class, right? So now if we run this, we have to just simply write java dot oops. Okay. Now we can see we get the result that is like, hi, my name is Alex and I work as a software developer. So this is how we populate our like the details. So now like that thing is clear as well. So if we have to now put something else as well, like put some other details, the age or the level of the employee, we can directly manipulate here, and then all the new objects will automatically have that detail, right? And even if we want to give some custom details, like we can give it here, so that if someone forget to mention that details, it will have some custom details like that are built-in sort of details, right? So this is how this works. Now let's create our different sort of constructors. So now the purpose of the constructor is to instantiate, right? The other purpose is we can also use this like constructor to initialize these values, right? So how it is done, let's see that thing in action. So let's create a constructor. So it should be, as we have discussed, it should be as same name of class name. So we can say employee, and then inside of this employee, because we are not going to pass this value. Like this is one way of populating the details. The other way is with the help of a constructor. So here we have to get the ID. So we have to say there should be int type of ID. We should be receiving whenever we are creating an object, and then there should be a string type of name, and or we can give it different so that you won't get confused. So let's say this is capital ID, and then this is name starting in capital N, and then there should be a string type of designation. Okay, now to populate these IDs. Now notice one thing, like because we are able to access the name, the designation, and the ID with the help of this keyword, now we should also be able to get these get the access of these things with to set them, right? We are getting them here, we can set them here as well. But one thing to notice is that like we have to move this function, because before setting them we shouldn't be printing them, right? So we'll do that later, but let's set them for now. So we can say like this dot ID, like this is referring to this ID, right? It should be equal to whatever the ID we are receiving in the parentheses, and then you can also say this dot name, that should be equal to name with a capital M that we are receiving in the parentheses, and then other parameters to get this dot designation should be equal to designation. Now we can remove these things here from here, okay? And let's see if it works now. Because now it's showing error. Why? Because we override this constructor, because initially Java created a constructor for us that is doing nothing, and that is receiving nothing in the parameter. But now we override this constructor. Now we must be providing these three details, because this is expecting to have ID, name, and designation. So let's create the John one now, right? So now let's pass 02 as ID, and then we can pass John as a name, and then we can pass what do you call it? Tech lead, whatever it is, tech lead as a designation. So these are just suggestions from the VS Code itself. I didn't write them. So now this is one way. This is the other way of populating the employee. Now, whenever we create this employee, we have to pass these three details so that it will automatically get like populated in the employee. Now, if we save this program again, and one thing to notice is that like we have to do like create a new bytecode for this, because for now it is having the old one, and if we run in this stage it will give us the same result as the last one. But if we create a new bytecode for this one, it will give us the new updated result. Now our bytecode is updated. Now we can run this program, and we should hopefully get the result that my name is John and I work as a tech lead. So let's see this in action. So now we did it. Like it's saying like, hi, my name is John and I work as tech lead. So these are different sort of constructors. Like we can have non-parameterized constructor that we see initially, then we can have parameterized constructor like this one, and then there is also concept of like copy constructor. We can just technically make the copy of the constructor. So this is the concept of constructor for now. So now let's move to our next topic, that is packages in Java. And this is a very important topic. Like this makes languages easy. Like most of the modern programming language, they are having more packages like than Java do, and that is what makes the language easy to use. So in general, packages are like the collection we collect, or are the collection of related classes that are interrelated and that are used repeatedly. So that we don't have to write them again and again customly, like in a custom way, but instead like we can use those packages that are written by either us or they are built in. Like in Java, there are two sort of packages. Like there are built-in packages, and then we can also write our own custom packages. So different packages, their built-in packages are like java.lang, which has like classes and objects, strings and threads, java.util, java.io, .NET, and that apply. And definitely we are going to see one of those right now, and then later definitely we are going to explore more of these packages. And beside that, we can also create our custom package. And to create a custom package, there are some predefined standards to create a package, how we should name the package. So it should be like we should give this keyword package, and then it should be like company specification, company name, then client name, then project name, and then module name. So this is like the standards to follow whenever we are creating a package for a larger project. But for now, we will just see these things in action so that we can understand like what packages and how packages do work. So let's first create our custom package so that we can understand the concept of like how packages work, what packages are. It technically we create a package, like create some details or classes in one package, and then we can import and use those details or those functions or whatever classes in our other projects, like in our other classes or something. And then there are built-in packages that we're going to use right now as well. So instead of going to our VS Code, we do have BlueJ platform as well, where I used to run the program, but it is a bit slower because it don't have autocomplete option now. But let's see how we create packages, like how our custom packages work. So let's create our new package, and then we name it as a pack. Okay. So instead of this pack, let's create one class that is that we call it as pack as well, and then we are going to use the information from this class into our class that we create outside of this pack. Okay, so BlueJ gives a lot of templates, like templates. We're going to remove this thing, and you can notice this. But when we create a package, and then when we create a class inside of that package, it is already giving us this syntax. Like this is keyword. Whenever we create a package, we have to write this keyword package and then the name of the package. And this name of the package should be same as the package, like in whatever we put this class, or like if the folder name or the directory name should be package if we are putting the class inside that package. So it is like this is a keyword, and this is a name of the directory inside of which we are creating the class, which belongs to that package, right? And now after that, like it creates a class, and the class name is pack as well with a capital P. Okay, so now let's remove this custom boiler code, and let's create one function that we are going to use in the different class. Okay, so let's create public void, and let's say function is just to custom package. So to create a custom package, let's say this function don't do anything except printing. It prints, okay, let's fill it as well, and it prints, let's say this is custom package from pack class, and then okay. So hopefully it should work. Let's compile this code. No syntax error, so we are able to compile this code. Now let's move outside of our package and create a new class here that is, let's say, oops for now. That is Object Learning Programming System, and let's customize this as well. Like, okay, we have to remove all this code that is public code from the Java. And now, as we know, we have to always create a main function to run any class. So we'll create a public static void main, and this is the problem with the function. Like we have to write everything manually. String args They don't give us the autofill feature. Okay, anyways. Instead of this, first we have to import the package, right? So let's import the package. Import, and how to import? This is how we import the package. Like we write the keyword import and then package name, like that is like pack, and then the class name that is pack with the capital P. Okay. Let's move it a bit different. And now we can create the object of this class, and whenever we run this program, it will like display that message, like whatever the message we have put in the class that is inside the package. So let's first create our class, the object of the class pack. Let's say custom equals to new pack. You have already seen like why we do this. Like whenever we create an object, we have to use the syntax. And after that, let's call that function. I don't remember. Okay, let's say that function custom dot that should be custom package, I guess. Custom package, most probably, if I'm not wrong. Okay, let's compile this thing and let's see if it works or not. Okay, no syntax error. Cool. Now let's run this program and let's see if we are able to run that thing, that whatever inside they're in the class that is inside the package. Okay, so if we do this. And okay, so it says this is a custom package from pack class. Okay, so why you might be wondering like why it is repeated, because I've already run this thing once, I guess that's why it's repeated, else it would have printed once only. Now I have to close the BlueJ and then restart it again, so then this window will be clearer. Okay, no worries. So we see how we create a class inside a package, and like how we create the package, a custom package. We have to just give a name, and that name should be the name same as the package name, and then inside of that we can create a class, whatever class and then inside of that we can create a functions like the methods, whatever we want. And to use those methods we have to use this importing statement and with the package name and then the class name, and then we can create the object of that class, and then we can use that functions or method or whatever there is inside that class. Okay, now let's get back to our VS Code, and let's see some of the. There is one important concept we haven't discussed yet, that is how to take user input. Like, because our program without the user input is just sort of a static movie, right? Where there is no interactability with the user. So let's learn about that thing. So to take a user input from the user, we have to use one package that we have learned right now, and that package is import java.util, most probably util.asterisk. Okay, so in this util package that hopefully we have seen here as well, this is util, and I told you that we are going to use this right now. Now to get the input from the user, we have to create an object of a scanner class. Like there is a class, like we have seen in this BlueJ system, there is a class inside the package. So this util thing is package, and star here means like this asterisk means include everything. Like we want to get everything. Suppose there are different classes, like for now there is only one class, right? But if suppose we create multiple classes and we imported only this package, right? But to import all the classes or everything that is there inside this package, we use this asterisk. So this asterisk means we are trying to import everything that is inside this package. Okay, so we are importing everything, and then there is a class. So we are going to create the object of the class. That class is called scanner, and let's give this object name as sc equals to new scanner, and there should be not a null. Okay, now to get the output, like to print the output, we generally use this thing like system.out.print. Now to get the input, we will use system.in. System dot. Okay, and hopefully this should be function. Oh, no, I guess. Okay, let's see. Now we create the object of this scanner class. Now with the help of this scanner class, we can take inputs from the user. Now let's say I want the user to enter their own name. Instead of like we providing a custom name, we will create it. Okay, so instead of doing this, let's do this thing somewhere above. So we are going to remove this to X. Let's clean up a bit. Okay, that's fine. We're going to create this object of somewhere here, and then we can do this thing. We can create like, so let's say string name equals to, and then we want, because we can get the input with the user with the help of this syntax like sc, the object that we have created, and then next line. So this, with the help of this, okay, you can also use sc.next, but the difference between the sc.next and sc.next line is that sc.next will take the user input, like the string, that until we met that, like until we met the spacebar. Like if I write sc.next and we, like, suppose tag the name John Mellon, so it will take only the John. My bad, it's a John. It's not a John. Okay, so it will take only John, but it won't take Mellon. Okay, but sc.next line will consider it all like as a John Mellon. So that's why we use sc.next line, and then we'll definitely see the other, like how to take the integer, the float, and like in that case we just create like sc.next int sc.next, and even if you want to see, we can see, like if you create, let's say, int age, let's say, equals to, we can also do this sc dot, it is also giving us the option for sc.next int there should be sc.next float and the double whatever value you want to take. There are options given, like this is how VS Code is helpful for us. So for now we are not going to take the age of the user, we are just interested in this thing. Okay, what's an issue? sc is never closed. Oh, the scanner is continue scanner system in the name. Okay, let's say instead of passing the name here, we can pass the name variable here. So now let's pass this thing, like let's see how this is gonna work. So first let's save our program, and after that, like we have to again create this thing, like the new bytecode. And now if we run our program, that is Java, oops, it should hopefully, oh, one thing, let's say we are able to type the input now here, John, and now if we run, it's saying, hi, my name is John and I work at Abstraction. But the issue is that, like, we didn't display any message. That's why user is not able to know that it is asking. So we can do one thing here, like we can do, before asking for the input, we can do accept, and we can give a custom method, like a prompt message. Enter your name. Now user will know that they have to enter their name. Okay, let's compile this code again. Okay, now let's run this code again. So now user is seeing this message like enter your name. Now let's user say, user enters their name as Alex, and now if we hit enter, now it's saying, hi, my name is Alex and I'm working as secretary. So in this concept, we covered both, like with the help of this input example, we covered like how to take the user input, and then how we create the classes, like objects from the classes. So this is a scanner class like that we have learned previously in our initial video, that's how to create objects from these classes, and also like how packages are used. So this is a pre-built package that we have imported, and then we are using it here. Scanner sc is closing it. So this is instead of like star, we can also import just the scanner thing, like import java.util.scanner. That will work fine as well. So this is the concept of how packages work in Java. So now let's move to our next topic, that is access modifiers in Java. Now this is very important concept, like whenever we are working with the like data hiding and like the next topics we are going to discuss, like the 4 main pillars of OOPS, then this concept will be used multiple times. And we've already used this thing a lot of times. Like you can see, we are using this public, everywhere we are using public, but there is not only public thing, and what does this public thing means and how it works, that's why we are going to learn about this. So let's start with the private one. So private means if we put the private in front of any class or any details, like any variable or data, any function, if we put this private, the keyword private instead of like public, like we are using public. If we suppose put private in front of this, then that class, that function or that variable will be accessed by only members of that class. What do you mean by that? Like if suppose there are three different classes in one package, and then there are two different classes in the other package. But if we create, okay, like in this case, we do have two classes, like we do have employee class, and then we do have this oops class. Okay, so let's suppose we try to create one private thing. Okay, let's say private and int age, or let's say int password. It should be okay string, but for our sake, let's say, and we give a password as whatever 12, whatever, like we'll do it later. But now if we try to access this password in this class, like you can see, like we are able to access this name, designation, and ID. But let's see if we try to access this password as well. And then let's try to okay, can we do this? Let's see this like the way we did here. So let's say Alex taught. Can we use the same password equals to, let's say 1 2. So now you can see here is the error. It is saying the field employee.password is not visible. That means we are able to access these things. Where we did it? Okay, we are able to access the ID, the name, and designation. But whenever we are trying to access the password, it is saying it is not visible because we put the private keyword in front of that. And let's remove this thing and let's see if it improves or not. But if you remove, it will be by default. It will be default. Now you can see the error is gone. So private means only the members of that particular class can use this thing, like use that data type or like that data or that function. So if you put the private, no one else, like even the classes of the same package, won't be able to access that thing, and we definitely classes from the other packages won't be able to use that thing. Okay, now let's see if we are able to use this thing inside, like how to access. Now the question arises: why do we create even the private things when they are not accessible outside of that class, and how to use them, and actually how to. So technically, I suppose if you're talking about like password or some sensitive information, we have to make them private sometime so that no one can accidentally update them. And then how to access them? So there is a concept of setters and getters. And even if you want, like we won't be able to suppose we have already set this thing to 12, like so we won't be able to even print this thing. If we try to print this thing, we won't be able to do that as well because this is private and this can be only used by this class. So now how to set and get them? So let's create this. So there is a concept of getters and setters. And okay, so let's do this, create this. So there are the functions because this class is able to use this, like this detail, like this password thing. That's why we can use this thing with the help of this class, like inside this class, and then return this and then set this as well. So let's first create a getter public because this is getter, so it should return integer value. So we'll create int, and then we can say get password. This is a class, and because this is a getter, it should only be called and it should return this value. And instead of this, oops, what's method must return a result type int. Okay. Get password because it's a getter. So let's say, okay, yeah. Oh, I got it. So it should be like we should be able to return this dot password. Now instead of like saying this thing, like instead of saying Alex password, we should call this function to get the password or to set the password. Okay, if we say this thing, so we get password and then just remove this thing because this is a getter function and this is returning something, so it should be stored in somewhere, or we can just print it somewhere. So we can say this thing. Okay, let's say s out, and instead of this thing, we'll print this thing. Show x because it is returning something, so we'll get this password. So this is how we access it. Like there is okay. So okay, my bad. It should be like this, and then this. Okay. Now, so to get the password, because this is private thing, so but this class is able to use this password thing, right? Because this is private to this class, but this class can use it. Now, in the similar way, we can use this setter. So we'll create a public, and if we create this thing private as well, then it wouldn't be of any use, right? But sometimes we have to create this thing private as well, because this is not going to return anything. So we'll create it as void, and then, but this will receive something of int. Let's say pass, and then we'll set the password. So to set the password, we have to say that this dot password should be equal to that pass that is entered by the user or passed by the user. So now to set the password, we have to do this thing again. We have to, okay, let's first set the password before getting it. So we can say alex dot set password, and instead of this, we can pass the password as 123, let's say. Oops, my bad. Let's save this. Turn issue. Okay, there are no. So now, okay, now let's try to compile this code and run it, and let's see the results, like how these getters and setters are working. Okay, it says enter your name. Let's say this time it's Bob. Okay, so it enters, it gets the name, then it prints the password that we have provided, not the password that we have set it here, the custom password. So that means we are able to set this private thing, and then it's print like, hi, my name is Bob, and I write as that. So this is the concept of private. Like it can be accessed by only the members of that class, and no one else except from the members of the class. Okay, now then there is a concept of protected, and now in this scenario, all the members from that package, whether like all the classes from that package, can access that data, like that variable or data, but also the members that are subclasses of that class. That means if we inherit this class, okay, we will learn about the concept of inheritance very soon. But if we inherit like this A class into D class, that means, and then the protected members or protected data values can be used inside the D class as well. Okay, so and for the default class, like whenever we don't put anything inside of it, like in front of it, like in this case we don't put anything, that means they are default. So now in the default case, all the members or all the classes of that package can access that data, but no one outside of that package can access that data, even if they are like subclass of that class. And if it is a public, then everyone from everywhere can access that data, whether they're classes of that package or classes of other package, and even if they're not the subclasses of that class. So this is the concept of like public, private, protected, and default in the Java. So let's we have already seen about the public. Like public is accessible all over the Java program. We have also learned about the private one. Now let's also do the protected one. And default, we also see the default one. These are default, so we are able to access it here. But now we have to just talk about this protected one. That is, we should be able to access in that package, and then we should be able to access in the other package as well. So this is in general the concept of protected one. Now let's move to our next slide. That is 4 main pillars of OOPS programming. So we have already seen the use case of like object-oriented programming, that we are able to create some sort of custom variables where we can store multiple type of data types and functions as well into one single unit that is called a class. But these are more important concept that like object-oriented programming promises us to give. So let's just start with the abstraction. So abstraction means hiding the complex details from the user and providing them the simple interface to interact with. Like if we talk about the switchboard case, so electrician hides all the details of like how wiring is done, how appliances are connected with those wiring, how it works, everything works internally, but provide us with a simple switchboard so that we can interact with and like use our different appliances. So this is the concept of abstraction, like hiding complex details from the user and providing them a simple user interface. Now let's talk about the encapsulation. So encapsulation means combining of data members and methods into one single unit is called encapsulation. So technically, we have already learned about this concept. So if you go back to our class example, like here in the employee class, we can see we have combined these data members and different methods into one single unit. And this is what is encapsulation is. Like we have different methods and different data members that are encapsulated or combined into one single unit. And this is what encapsulation is. And with the help of encapsulation, we achieve the feature of data hiding. Now there is difference between detail hiding and data hiding. Like, with the help of abstraction, we hide the complex details, but with the help of encapsulation, we hide the data itself. Now how we hide the data is that like with the help of these access modifiers, like whether it's a public, private, or protected. So we have different level of data hiding. With the help, we achieve this thing with the help of encapsulation. Now how we can see that is that because we are encapsulating some data members and methods into one single unit that can be either used by only that class or class from those from that package, or the classes from different packages. So we also try to achieve the concept of data hiding. And why do we use data hiding? We have already told, like sometimes we don't have to tell we don't have to give access to all the classes or all the methods so that no one can accidentally update some sensitive information. That's why we use data hiding. So with the help of encapsulation, we are also achieving the concept of data hiding. Now third part is inheritance. Inheritance means to like inherit the properties like the data members and methods from their parent class. Suppose we talk about a case of a dad and a child. So we can say like a child inherits a lot of properties from their parents, that is from theirs, in this case from their dad. So suppose this child inherits the facial feature from his dad, hair pattern from his dad, height and width will be from his dad, he's also able to walk like his dad, but the child can also have some additional properties, like this child is able to swim where his dad is not able to swim. So technically, when we inherit, some other class, like suppose there is a class A and then there is a class B. So if class B inherits class A, that means class B is not able to use all the properties, like except the private features, all the properties from class A, and they can create their own custom as well. Right, so we'll explore this topic in more details further, but for now, the general overview of inheritance is something like this. Like if there are different methods, like there are these are our public or default data types, and like data are of this class, and these are public methods. So if any class inherits this class, that class will be able to use these methods and these data types. Oh, okay, these data. And now the final pillar, or the fourth pillar, is polymorphism. So poly here means many, and morphism means form. So we do have methods that do have many forms. We'll learn in more detail as well. But for now, it is sort of like if we talk about the water. So water is simple water, but it could have many forms. Like it could be in the form of ice, or whether a liquid or a gas. So these are like different forms of water, but technically they all are water. But for different use cases, we do need different forms of water, right? So this is what polymorphism in general is, but we'll definitely explore the topics in more details. So let's start with the inheritance itself. And so there are several types of inheritance. So there could be a single level, multi-level, hierarchical, or hybrid inheritance. So let's talk about this. So in single level inheritance, there is a concept of like the parent class and the child class. The class which inherits the property from the other class is called child class, or the derived class. And the class from which it inherits the properties is called the base class or the parent class. Or in some cases, we also call it as these parent as a superclass and then child as a subclass, right? So we can take examples. So suppose there is a class animal, and then there is also a class called aquatic animal. So animal derives the property from the aquatic animals derive the property from the animal class. So in this case, there is only single level of inheritance. That means one class is inheriting properties from the other class. But there could be multi-level inheritance as well, where there could be a derived class like the other class extending or inheriting the properties from one direct class. That means there is chain of derived class. That suppose this is class A, this is class B, and this is class C. So class C is inheriting property of class B, and class B is inheriting property of class A. That means there is a chain of classes that are inheriting properties from each other. So what will happen here is that like class B will have all the properties of class A, whereas like class C will have all the properties of class B. Technically, it will also have all the properties of class A, because in this case, we can see like because this class has already inherited properties of this. So when this class will inherit properties of this, so it will technically have the properties of this as well. So we can take the example. Suppose there is some Nemo fish. So fish inherits the class aquatic animals, and aquatic animals inherit the class animals. So technically, fish will have properties of aquatic animals as well as animal too, because aquatic animals has already derived or inherits the properties of animal class. Now there could be a hierarchical inheritance. So hierarchical inheritance means when multiple classes inherits the properties from one single class. In this case, we can see like there are terrestrial animals or aquatic animals. They both are inheriting properties from the one class that is animal class. So in this case, we have multiple classes that could be more like aerial animals or some other animals that are also inheriting the properties from the animal class. So this is the concept of hierarchical inheritance. And then finally, we do have hybrid inheritance as well. Hybrid inheritance means when there is combination of all single level, multi-level, and hierarchical inheritance, or there might be a combination of two or more of them, then we call it as hybrid inheritance. In this case, we can see like the animal is like the terrestrial animal, aquatic animal are driving or inheriting the properties from the animal class. That means it is like the concept of hierarchical inheritance. And here we can see like animal is terrestrial animal is driving the property of animal class, that is single level inheritance, and then there is a concept of multiple level inheritance as well. So these are four basic type of inheritance. But in Java, there is one more concept of multiple inheritance. This is multi-level, but there is one more concept of, if you are from C background, you might know this concept of multiple inheritance. Now let's talk about that. Why Java don't allow multiple inheritance, and why other languages? What's the issue? Suppose there is, okay, let me put a pen. So there is, suppose our parent class, okay, and in multiple inheritance, it is sort of like there are two parent classes. This is P1 class, and then there is other parent class, P2 class. So in multiple inheritance, what happened is that the child class inherit properties not from single parents but from different parents. But why Java don't allow multiple inheritance? Let me write multiple. So why Java don't allow multiple inheritance is that suppose there is some feature like suppose there is one method, let's say legs. This parent say has final property of leg, that means it cannot be changed, and it has 4 legs, and it have like the final legs as 2 legs. So how will this child decide whether to take these legs from this parent or this parent? Because this is inheriting properties from both. This is very basic example. This actually doesn't work. Suppose there is a function called move, let's say. Now this is trying to move by walking, but this is trying to move with the help of swimming. There is a function which says how animals move. So how will this child class decide whether to take the property from this class or that class? So that's why Java don't allow multiple inheritance, but there is a concept of interfaces that is technically allowing multiple inheritance, but we do have the concept of abstraction there. We'll talk about it later in more details. So now let's like implement these concepts first, like the concept of inheritance. So for our inheritance, let's create a new class now. Should be inside this folder, hopefully. So we can say inheritance Java. Okay. So now to implement this concept, we need to have like multiple. We are going to take the same concept of like animals and like this aquatic and terrestrial animals to show all the type of inheritance, like single, multiple, hierarchical, and hybrid animal or like inheritance. So let's first create our class animal. So to create a class, we already know like we have to use this keyword class, and then we can say like give it a name, animal, and let's say this animal is having a data that is called legs, and then there is also a method that is, let's say, move. So we can say we can make it public for now, public, because this is not going to return anything. That's why we are going to use void, and then we can say move. Okay, it's not going to accept anything for now. And inside of this, let's say let's say breathe. It will comment because moving will be different. So we will implement the move function in different like subclasses differently. So let's say breathe. Okay, and now we can do this thing. It's out, and inside of this, it will tell I'm alive and breathing. Okay. And now let's create a new class that is called, let's say, aquatic animals. So we'll say class aquatic. And now to inherit this animal class, we will use this keyword that is called extends. And then we'll write the name of the class that we want to extend, that is our parent class. And inside of this class, let's say for now we didn't create anything, and let's say if it is able to inherit this class, like if it is properly inheriting this class, and because we are going to call this function with the help of a method object that we are going to create for this class, and let's see if this works or not. Okay, so let's quickly create our like main function, public static void main, and then instead of main function we have to pass string works. We can also do it towards exception and all, but for now, let's leave it. And we're going to create a class with this aquatic. Let's say AQ equals to new aquatic. Perfect. And now we are going to say AQ dot breathe. So according to this, there is no method in the aquatic class that is called breathe, but because this class is inheriting the parent class that is animal class, and there is a method called breathe. So hopefully we are able to print this thing like I'm alive and breathing. Okay, so let's save this program quickly and then compile this one. So we have to say Java C inheritance dot Java. Okay, seems to compile successfully. Now we have these classes like inheritance, aquatic, and animal. So now let's run this thing and let's see if we are getting the result. So Java inheritance. Hopefully we should get the same. Okay, now it says I'm alive and breathing. That means we are successfully able to inherit this class. Now you can understand this concept now, because there is no method in the aquatic class, but because it is inheriting the property of this. Oh, also we can do this thing. Okay, we can also do this thing like aquatic. We can set the number of legs that aquatic animals have. Let's say aquatic animals have 0 legs, so we can also do this thing. Like we can say eq dot legs equals to 0. So still you can see there is no data that is called, or attribute that is called legs in the aquatic class, right? But we are able to set these legs, and let's also implement, like, check it out if it is working or not. So we can say out, and instead of this, I have number of these many number of legs, let's say, and then we'll do this thing. We'll do plus sign, and then we say eq.legs, and let's save the program, compile it again, so we can do this thing. Okay, hopefully it should work. So now it say I have this many number of legs, and then it's saying 0. So you can see we can use all the data members, like data and the methods of the parent class in the child class where there is no method. And now we can also create the custom methods and data type, like data variables, instead of this class that are custom to this class. Let's say we create move for this method, so we can say public, because this is also not going to return anything. We'll say a void, and then we can say move. And this method also not accepting any parameters. We have to just move this element. That is because this is aquatic animal. So we can say fish is swimming, whatever. Fish is swimming. Now we can call this function as well. So we can say aq out. Now you can see there should be option for move as well. But okay, did we do this? Okay, let's do this. Let's see if it is working or not. Let's compile our code again. So perfect, there's no issue. Now there you can see I'm alive and breathing. First, this function is called, like this method is called, because we have called this method first. Then it is calling its own custom method, and then it is also using the variable, like the data type that is that is the property of animal class, not the aquatic class. Now this is sort of single level inheritance, like there is one animal class, and then aquatic class is extending that animal class. Now let's move to multiple inheritance. That is, let's say we talk about there is a class called name of fish, let's say now, and then it extends the class aquatic. Now it should get all the properties that, like the data members and methods of this class as well as this class. Let's see now, because right now we don't have anything inside our Nemo class. So let's create our, okay, let's comment out this one. Yep, we can comment out this one, hopefully. And then now we can create a new object for the Nemo class. So we will say Nemo is a fish, and nm equals to new Nemo. Now let's see if we are first able to use this method, like the breathe method. So let's see nm dot. You can see there is option, like VScode is already giving us this option of, like, if they can breathe, like if we can use this breathe method for this Nemo class or not. Okay, so now let's compile it again. Okay, by the way, I'm using like up arrow key to use the last commands. You can use that as well. No, it is saying I'm alive because I've commented out this one. That's why it's saying I'm alive. Now let's create a custom method inside of this as well. Let's say make sound, whatever. So we're going to say public void make sound. So suppose this is a method, and now we can say this out. Nemo is making sound, whatever. Nemo is making sound. Okay, let's save this thing. It should be able to, let's compile now. Perfect. So why it isn't called? Because we didn't call this method here. So to call this method, like to get the result, we have to call this method, right? So we have to say nm dot make sound. Now if we save the thing and compile it again, it should work, right? So like these are some mistakes. Like sometimes we forget putting the calling the method and all, and these are like the method, not the constructor, that are implicitly called. These methods we have to call them explicitly. So we forget this thing and we think like we had made the mistake. Okay, compile well. So now we can see like Nemo is making something. So this is sort of like multi-level inheritance. Like we are able to, like Nemo is inheriting this aquatic class, and this aquatic class is inheriting animal class, but we are able to, with the help of like in the Nemo class, we are able to use the functions or method or data types or variable or whatever there is, like the data members or method of aquatic class as well as animal class. So this is the example of multi-level inheritance. Now let's create one more class that is terrestrial animal, and then we will be able to see the example of both hierarchical inheritance as well as like hybrid inheritance. Because okay, let's first create it. Explain it. Class terrestrial. Okay. Okay. It should extend animal. Animal. And now it will have its custom method of public void move, and here it will, instead of like swimming, it will say walking. S out. Oh, what is this? Okay, S out. Or we can say, let's say horse. Oh, it should be custom animal. We can say animal is moving or walking. Sorry, walking. And now we have to create this thing. Oh, let's comment out this one as well. And we have to create this. That is terrestrial. Terrestrial or equal. This is convention, right? Like you can use anything here. The name of the object. This is like convention, and I like it. And now we can call this thing like move on this to your object, to your dot move, as well as we can call other thing like we can also call this function like tier dot breathe as well. Okay, and we can also like override these concepts. Oh, we will take them later. Like tier dot breathe. Okay, so for now let's save this thing, compile our program, and then run our program. So let's say animal is walking, I'm alive and breathing. Now let's like override this function. Like we'll see the concept of like, can we override this function breathe like in the terrestrial animal? So let's copy this function. Okay, Control C. And in the terrestrial animal, we paste this function. Now, if we call this function, instead of like I'm alive and breathing, let's say I'm alive and snoring. This animal is sleepy. Okay. So now let's compile our program again and run it again as well. So you can see like it says now animal is walking, I'm alive and snoring. That means if there is a method that is like different in parent class, but we can override this method in the child class, and we will see the concept of like method overriding later when we are learning about the interfaces, because this concept is very important when we are talking about like the multiple inheritance as well. So we covered all the topics of like single level inheritance, multi-level inheritance, and hybrid inheritance, like also the hierarchical inheritance, and we have also seen them in action. So now let's move to our next topic, that is polymorphism, that we have already talked about. Like it poly means many and morphism means form. So suppose in this case, okay, there are two types of polymorphism. There is like compile time polymorphism, and then there is runtime polymorphism. So difference is that one is achieved in the single class. Like whenever we are working in the single class, suppose we create a method. Okay, there is a suppose class area, and then we do have different shapes like the squares, the circles, the triangles, the rectangles, and we have to like calculate the area of all the classes. So what we will do is that like we will use that same method, like the same method that is area for all, to calculate the area of all different shapes. But the thing is that like we will pass different parameters or something, we will make something different so that compiler will know like how to differentiate that between them, like what to choose, like for which method we should go, else it will get confused, right? But there is also a concept of runtime polymorphism that is we sort of did here. That is like a in the interfaces actually we don't implement these functions or methods. We just give them the name, and then it is duty of the class that is inheriting or like implementing getting those interfaces, like extending those interfaces to implement those methods. That is the concept of like runtime polymorphism. In there, we compiler don't need to decide for which method we have to go, because each class is having its different method, right? So here is a simple like example of what it's like. If you go to coffee shops, so suppose there is a concept of like the waiter come to you or the server come to you and ask you whether you want a coffee with sugar or without sugar. So there it is already defined. Like whatever you will ask, it will give you the coffee according to that. Like if you ask for the coffee with the sugar, it will give you coffee with the sugar, right? So waiter or the cook already knows like what exactly you want and what exactly to serve to you. But in the runtime polymorphism, suppose you go to like the coffee shop and they don't ask you, they just serve a plate with the like coffee, the sugar, the cream, and other options. So they don't already know like what you are going to choose for, but they give all the options to you, and you will like create your coffee or make your coffee according to your custom needs, right? So this is sort of different. Like one way we like in the one case we already know from like exactly where we have to go, and in the other case we don't know. We have just the concept, like idea of like these are the options, and like you can customize according to your need. So this is just a simple example, all right? So let's see these things in action as well. So I should create a new class for this as well. So I will call polymorphism.java. Let's see. Cool. So now let's create our shape class that will also give us the area. Or yeah, we can class and then we shape. We call it shape. So this class, okay. So this class will have the name of the shape. Let's see. So we can give string name, whatever the name of the shape is, and then it is also helpful to calculate the area of different shape. So let's say we have first we have to calculate the area of let's say circle, area of circle, and then we have also the concept of area of rectangle. So now we will create two methods with the same name. Like we can see public because it might return, but let's for now we are not going to return anything, but it can return like integer value or some floating value, right? Like we can return something. Oh, or let's return things like so we can know like how to return as well. Public float, and then we'll give this name area, and it will, because it is a circle, so it also like it only need is the floating value. Or we can say we can give it radius and integer or something. Oh, let's say float radius. Now with the help of this function, we are going to first some issue, I guess. The method is return. Okay, it is saying like we should return something. Okay, but we are going definitely going to do that. So let's create int area. area, perfect, equals to. It is like pi times r squared. So we can say this thing. We can say 3.1 for something times r. We can do this. Radius. Oops. Radius times radius. So this is technically the area of the circle. Now we can return this. Return area. What is this? Radius. We don't need this. We are going to just return this thing, like this area. What is the issue? Okay, we have to solve this. Can I convert float double to int? Okay, it is saying. Can I convert this to this? Okay, perfect. Can we put these things inside parentheses? This one also. It's saying mismatch. So double to int Java. Okay, it is saying this is a double value, or we can do this thing. Can we also get this thing? Float is this and to int. Oh, sorry. Actually, I did it here. I made a mistake. My bad. And then this is quick fix. Perfect. Perfect. This is typecasting actually. Like it is considering these values as like. Although I have mentioned this as a float here, but this is like it is considering this as a double. Okay, but this is a floating value. So it now this is called typecasting. Like whenever we have to like typecast from one data type to another data type, because okay, difference between I guess I have already told this thing, but just to clarify, difference between double and float is that it is like less precise. Like float is less precise, and double is more precise. Like the value of the decimal is like more precise in the case of double. Okay, now let's create our rectangle function that is also going to be area public. And okay, let's say okay, we can also like do this thing like we can instead of like returning float, we can return int as well. This is also like to make difference because we cannot create two methods that are having same name with the same return type and the same number of parameter with the same name, right? Like with the same return type, like a very data type. So we are able to create area, but in this case, because this is also you can see this is also float, this is also float, this is also area, this is also area. So whenever compiler start to compile, the compiler doesn't know which area we are calling. But from now, like from this thing, let's say int. Okay, this thing is one different. Now, if we pass the float value, it will know like we are calling this function. If we pass the int value, it will know that we are calling this like the area function, the area of rectangle. But let's say we also take like we take the float value here as well. So now how it's gonna make let's say length. Now in this case, how it's gonna make difference because both are return type. Like the return type in both the cases are same. The name is same. The parameter, like the data type in the parameter is also same. So, but now here we will like take different number of parameters. So now we can see like now compiler will know like if we pass one floating value that it will know like we are calling this area like this this method. But if we pass two values, then it will know we are calling this method. Okay. So now let's calculate this thing. Instead of like we can directly do this. Return length in times breadth. We can also do this. This is just a shorter form. Like in this case, we can also instead of like returning the area, we can also do this thing like copy this thing and return it directly. So now we successfully create our shape class. Now let's move to our main method. Like let's create our main function, public static, and then void main string of args. Okay. Now inside of this, we have to create this thing. Like create the sh. Let's call it equals to new shape. And now, no, yeah, we can call this thing. Like we have to call these methods, right? First, we have to give them name. So let's say the name of the okay, this is sh. shc is like shape circle, and let's create the object for the other one as well. Okay, dot shape shr is like the rectangle name. Now we create like two different objects, right? So now if I have to call them this method, and now we have to give the name as well. So we can say shc dot name is circle. Oops, it should be string or cle circle and shr. Oh, let's call the function first. So I can say shc shc dot area. And now we have to pass in value. It should be whatever. So let's say it is our greatest length is 2.5, whatever. Okay, now close this thing. Why it's showing error? The method area is in the shape is not applicable for the arguments double. Okay, it is considering it as double. So should we create? Okay, can we do this? We can do this. Example: float radius equals to 2.5. Like whenever we put a value like this, it considers it as double. So instead of like passing this value, we will pass the same radius. Now hopefully the error should go. What is this? Mismatch conversion. Okay, we can typecast it. Typecast. Okay, perfect. Now we created a float value and then pass it there. And okay, is it printing? It is returning. So we should store this value. Okay. Float ARC is area of circle. So now whatever value, like because we are returning some float value from this method, now this value will get stored inside this variable. Okay. So now we can like print this as well. We can say this out. Area of or circle with radius 2.5 is, now we can do this thing and then we can add ARC. Oh, ARC. Perfect. Now whatever value it will return will store in this ARC, like this area of circle variable, and then it will be printed here. Now let's save the program and compile it. Now let's see if everything is working as intended. So I'll clear the console. Okay. Okay, so we can do this in Java C polymorphism .java. Hopefully, okay, perfectly. We created this bytecode. That means everything works fine. There is, okay, there is an issue. No issue. Okay, this is just a warning that we didn't use this variable we created, but we didn't use it. No worries. Now we can say Java PHISM polymorphism. Okay. Okay, now it's saying area of circle is with the radius 2.5 is 19.625. So perfect. We are able to call this, and now let's do this it for this one as well. So we have to give it a name. We can copy these things from there. Copy and then comment these one out, or maybe not. We want to comment them out so that we can know like we are successfully able to call both the methods at a time. So instead of like radius, we have to say length. And length is not 2.5, it is, let's say, 3.5. It should be AR of rectangle. And we need to have one more variable, that is breadth. And then we call it as purely edit breadth, and perfect. And it should be 1.5. So instead of like calling the area for this, instead of passing the length and the breadth of radius, we'll pass length, comma, breadth. Perfect. Perfect. Now instead of this, we'll do this. Is there anything else? Oh, one thing. We have to do this for shape rectangle. Now it should work. Like whatever we are doing here for, okay, let me get them specific. Whatever we are doing here for the circle, we are doing here for the rectangle as well. Now we can see like we are able to call like both the areas, and we should hopefully get the different values for like the area of circle, and we are able to successfully call both different methods with the same name and same return type. So now let's compile our code and then run it. Perfect. So now we can see area of circle with the radius. Sorry, I forgot to update this thing, but it is giving different values, right? Like it is like pi r square, and then this is length into breadth. Or hopefully I did this. Perfect. So we can say here area of rectm rectangle with not the length, but instead length gt length is 3.5, and we can also put this thing, and the breadth is with breadth 1.5 is this. Save our code, run it again, compile it again, and run it again. So now it's perfectly like working perfectly fine. Like area of rectangle with the length 3.5 and breadth 1.5 is 5.2 and area. So this is the example of like compile time polymorphism, where we do have the methods with the same name, and might be saying it like there should be some differences. Like either we need to have different return type, or okay, it could be we can have different return time definitely, but we should have at least like either different data type, like different types of parameters, or like different numbers of parameter, or maybe the different sequence of parameters. Suppose there are only two parameters, and both are float, like one is float and the other is int or string. So we can also like alter the the sequence of parameters to make a difference, so that compiler would know according, like if we have, like suppose there is int and a float value, so we can pass like the here in this case it is like float and float. So suppose we have int and float, so what we can do, like we can create other method area, and then we can pass like float and int. So whenever we call that function, like whenever we call a method, we know that we are calling this exact function because we are passing the different values, like the float and int, or float and float, or int and float, whatever values. So this is how the compile time polymorphism work. And for the runtime polymorphism, we see the slight example of like how it works. Like first we implement this thing, like we implement the concept of the we create the method in the parent class, and then we don't implement that there. And this thing we do in like the interfaces. Now let's and then we have to implement that thing inside the child class or the subclass. That is a concept of like the same method with the same name, and that is called runtime polymorphism. And it the child class set that like method or the function according to their name, like how we talk about in this example. Like they will give you example like choices is up to the child class, whatever they set. There is no predefined calculations or options available. It is just everything up to child class. So now let's move to our final topic, that is abstraction. So first let's talk about, okay, we can create one more class for to see the concept. We have already learned about the abstraction, what it does and how it does, like how it hides the details, right? The complex details. But exactly how it works, so now let's talk about that. Okay, so let's start with what abstraction is. So let's see the definition first. So abstraction means like we already know the definition, that it is used for detail hiding. So what are the other things abstraction can do? First part is it can have abstraction level from 0 to 100%. That is, can have abstract and concrete methods. What do we mean by this is that, like, if we create a class that is an abstract class with the help of abstract keyword, so it can have abstract as well as concrete method. That, like, it is not mandatory that if a class is abstract, so all the methods should be abstract as well. But the reverse is mandated. Like if there is any method that is abstract inside the class, then abstract like the class is need to be abstract as well, right? So what do I mean by 0 to 100 level of abstraction is that, like if suppose there are all concrete methods in the abstract class, then there is 0 level of abstraction. But if there is like 100%, like all the methods are abstract methods, then there is abstract, like 100% abstraction. So we can create a mix of that, like anything in between that. But in the interfaces, like if we talk about the interfaces, there are all the abstract methods. But later, like in Java 8 or 9, they have made a little slight changes that we'll learn later. But for now, just understand, like interfaces do have, like interfaces are used to achieve pure abstraction. That is, like all the methods in general are abstract. Like by default, they are like public and abstract. If you don't even write them, right? Else, like in the case of abstract classes, the methods are default, not the public, right? So second thing is that class must be declared with the abstract keyword. So obviously we will have to declare the class with the abstract keyword. And if any of the method of the class is abstract, class should be declared as abstract as well as, but vice versa is not true. We've already talked about this thing and it cannot be instantiated. So one thing about abstract classes as well as for interfaces is that we cannot instantiate the abstract classes or interfaces. That is, like we cannot create the objects of abstract classes or interfaces as well. Like we cannot create the objects. Methods with no body is known as abstract method. That is like whenever we have to create the method that has no body, like whenever we want the child, like the child class, whatever, whichever class inherits that class to implement that method, and we don't want to give the details in the parent class, then that class, and we don't give the body of the class, that class is called abstract class, and that like that method is called abstract method as well. And then we have to put the abstract keyword in front of that method as well. If a class is inheriting abstract class, it is mandatory to implement all the abstract classes. Okay, there should be abstract, not classes. There should be methods in the subclass, right? So it is like that. Like if any class is inheriting the class that is abstract class, so that class, the subclass or the child class, has to implement all the method. It is mandatory to implement all the methods that are abstract in the parent class, right? we achieve the method overriding with this concept of implementing abstract method in subclass. So I've already talked about this, but we'll see this in action again, that we achieve the concept of like multiple inheritance with this help of abstraction, right? So let's move to our VS Code and like see these things in action, like how they actually work. So I think like we should create a new class for this as well. So we can say abstract.java, let's say, okay. So now let's move back to our animals example. So now we will create a class that is abstract class this time. Okay, now let's first create it without the abstract class animal. Okay, and this class will have, okay, let's say animal, whether it is whatever, like aquatic or whatever. Well, let's take different example now. Let's say omnivores, herbivores, so carnivores. So like what type? Int or string should be, right? The string type. And we can like declare this thing because this is abstract. That's why we are not going to do anything. And now let's say eats. Like let's create a method eats. Like okay, let's say void eats. And suppose we don't have to because there are going to be different types of like whether they are herbivores, carnivores, or omnivores. So we don't know what they are going to eat right now. So we want it to like we don't want to give the body here, so that child like the classes that inherit this class should implement this. So now it's giving error. Like if we don't give the body, it will give the error. And this says this method requires a body instead of like semicolon. So it is saying that we cannot put the semicolon here, but to create the abstract method, we don't need to get the body. So for that, we can use this keyword abstract. Now, if I put the abstract keyword, it should, like technically, it should remove the thing, okay? The abstract method eats is type animal can only be defined by the abstract class. Now, it is telling the error is changed. Like here, it is not saying we cannot use the semicolon, but it is telling us that this class is not abstract. That's why we are not able to create the abstract methods in it. We have talked about this thing. Like if the method, any of the method is abstract, we need to have abstract class. But the vice versa, that is, if the class is abstract, we don't necessarily need the abstract methods. So let's put the abstract keyword here as well. And now these errors are gone. You can see like this class is now abstract class, and then this method is gone. Now let's create our other classes that are like let's say class herbivore. Herbivores. Let's say it will. We can also define this thing, but let's don't worry about that for now. Let's just implement it. And one thing, we didn't extend that class. That's right. Let's extend that class first so that we know like animal. Now you can see like we got an error, and this error is saying the type herbivore must implement the inherited abstract method animal eats. So it is saying like if any method or like if any class is inheriting the abstract class, so it should implement all the abstract method that are there in the animal class. Now let's say we create other method. Let's say for now general random test method. So we say void test, but this method is having body. So this method is saying something just testing. So now still you can see still there it is not saying we have to implement that test method, but only the eats method, right? So that means like if the method is concrete, it is not necessary for the child class to implement that, but it can also implement that as well. We have already seen in case of inheritance. But if the method is abstract, we have to necessarily implement that method. Okay, so let's implement that method that is void eats. So we have to also say, and also one thing, like because this is okay. Let's see. I'll show you later so that you can understand. Void eats and it's out because this is herbivore. Eats grass. Let's say eats grass. So now you can see the error is gone. That is like now it is not showing the error that we can do this thing. And now let's do one more thing. But one more thing is that okay. Let me first compile this so that we can know what's going on there. Jealousy. This is abstract. Okay. Last name is abstract.java. seems to work. Okay, let's now run it. But the problem is that like we didn't create any object, so how it's gonna work? So first, let's create a main method, public static void and main. And instead of the main, we have to say string string args. That. And instead of this, we have to create the one more thing. One more important thing is that like, can we instantiate this abstract class? Let's see that. Let's check like that. Okay, so let's try that. Animal anm equals to new animal. Oops, Control Z, new animal, and let's put this in. So we can see it is giving us error, like cannot instantiate the type animal. Like it is telling that because this is abstract class, that's why we cannot instantiate this thing. But if you try to create the object of herbivore, let's try that. Can we HB, let's say, and then new herbivore. Now we can see like there is no issue with this class, and we can also call this method like the eats method, and also we can implement this value like a string. Okay, let's see. HB dot type. Okay, let's say it is herbivore. Oh, it's okay. Herbivores, and then we can also call this method HB dot eats. So now let's save this thing, and then we have to do that thing again. Like we have to compile it again. Perfect. Now let's run this. Java abstract abst. Okay. So it's a eats class. That means we are now successfully able to run this thing, and we see the concept of like animal. Like we see the concept of inheritance as well as abstraction. Like we are able to create this abstract class. Now, one more important thing. So this is technically how abstract things work. Like we can create abstract classes, and then we can also create abstract method or concrete method inside of that classes. But the important thing is we have to notice that like if we are creating the abstract method, then we have to implement that method in any of the child that is like inheriting that abstract class. Now let's see the concept of interfaces. So can we do this in the same class? I'm not sure. Let's see. Okay, let's create interface. Okay, to create the interface, we have to use this keyword interface. Technically, Control Z, interface, and then let's call this interface as the provider category. That is terrestrial. Let's say terrestrial, and because inside of this, like just notice these things, all the fields. Okay. This is same as abstract classes, but with all the methods are public and abstract by default. So whatever method we create in here are public and abstract. Like in this case, in the case of abstract classes, the methods are not public and abstract by default, but we have to tell them if they are public or, but by default case, they are like default methods, and if they are abstract or not, we have to tell them. And if we have to make them public, we have to put the keyword public. But in the cases of interface, all the methods are public and default, like public and default by default, like public and abstract by default. And in the case like it is sort of like blueprint. Interface is sort of like blueprint for classes. Like classes are blueprint for objects, and interfaces are sort of blueprint for classes that tells the classes how to work, but like what to do, but not how to do. Right? Like how do the classes will do it at their own, but what to do, interface will tell them exactly. Okay, the other thing is like all the fields that are like data members are public, static, and final by default in the case of interfaces. Concept of multiple inheritance can be achieved with the help of interfaces. Okay, so interface can also use. Okay, one more concept we covered is there like what we were learning about like method overriding, that is polymorphism. So we can see like the method name is same, the return type is same, the number of parameters are same, and then we are overriding this concept. So this is the concept of runtime polymorphism as well. So we covered that concept here as well. Okay, so the other thing is that like the concept of multiple inheritance. Now we will see this concept like what we were talking here. Like there are two parent classes and then one child class. So how will it like inherit those two classes? Like if there is one method that is like both are having same method, like the child, which method child should take. But in this case, suppose because both the interfaces are having same method but no body, so actually child have to implement their own method, like have to implement that method. That's why it is going to use that method only. That is why the possibility of multiple inheritance is achieved with the help of interfaces. Okay, so these are, it also helps in achieve loose coupling. What does loose coupling means is that like there is less interactability between the classes and the functions, so that like if we make changes in one class or one method, it is not affected, like it won't affect the other classes. And there is the concept of loose, this is the concept of loose. And we try to achieve this thing like as far as we can, like we try to create a program that are not tightly coupled, that are not dependent on each other, so that if we are making change in one, we have like it will affect all the other classes and all the other methods. Okay, so now let's get back to our this thing, interface thing. Okay, so interface. Okay, so let's say because this is terrestrial animal, so let's say it can be herbivore as well, but there is concept of walking or speaking. Let's say it speaks or makes sounds. So let's create a void makes sound. Okay, makes voice, we can say, because this is somewhere I should like this. Okay, so now we don't have to tell it that, use this keyword abstract here, because it is like by default public and abstract. So we don't have to tell them that this is like abstract or not. Everything, like all the methods there are like by default public and abstract. So now let's see if we are able to, because herbivore can be terrestrial as well. Now, okay, let's see. We create a carnivores. Control Z. I'll make this mistake again. Carnivores. So now to implement or inherit the classes, we use this keyword that is extends. But to like use the interface or inherit from the interface, we use keyword that is implements, and then we can give the name of interface that is terrestrial. And now you can see, even if we create a class, because we don't tell that this class is abstract, it still is giving us error, because if we are implementing the interface, we have to declare, like implement all the methods there, so that there is no error. You can see that the type of carnivore must implement the inherited abstract method that is terrestrial.make voice. Okay, so in this case, let's say this is lion. So let's implement that. We have to tell them void make sound. Okay. Okay. This is a method, and it's still, let's say s out. My bad. S out and roars. We can say line roars. Okay, but you can see, like we implemented this method, still we are getting this error. You know why? Okay. Actually, this thing is not this thing. We accidentally use the other method. Now you can see, like, okay, this error is gone because we implemented the what makes voice, but still there is a visibility issue with that, because this method is public and abstract by default. But if we create any method, like override a method, that is in Java, it is considered as default if we don't tell it. So for now, so in this case, we have to tell that this method is public. So that is why it is saying like visibility issues, right? Cannot reduce the visibility of the inherited method from terrestrial. So if we write the public here, then this method, like this error should be gone. So whenever you are like implementing the method, because this method is public and abstract by default, so you have to tell in the child class that this method is public, right? And then you have to implement that method. Okay, now let's save this program and compile. Okay. Okay. So for this class as well, we have to create an object. Let's create carnivores cr equals to new carnivores, and let's say cr dot make something voice. Perfect. Now let's compile our program and run it as well. Okay, you can see like eats grass, the herbivore is eating grass, and lion is roaring. So this is how like abstraction, like the abstract classes work, and then this is how our interfaces work, right? So one more important last concept is that like I said like we can achieve the concept of multiple inheritance with the help of like in these interfaces. So now let's create one more interface. That is called, let's Control C. And now this time, instead of terrestrial, they are supposed. Okay, whatever. With the terrestrial, they're also what? They're also carnivores, or they're also no, not carnivore. Okay, okay. They're just animals. Like we are talking about the general animals, or like let's talk about the carnivores, or maybe something else. Let's say omnivores. So they're omnivores. Omnivores, omnivores, and then omnivores. In this thing, like instead of make voice, we let's say what they eat or how they walk or moves. Okay, because they are both terrestrial and omnivores. So, okay, now let's create the other category. That is, let's talk about the omnivore that is bear. So let's create a class bear, and then it implements both the classes, like both that is like the terrestrial and omnivores. Like bear is terrestrial as well as omnivores. So now you can see like we are able to implement like inherit two classes at the same time. Now we have to like because these both of the methods are like abstract and public, so we have to tell like implement both of them. That is like make voice and moves. So we have to tell that it is in the public, and then void, and then make voice. This is the method. So let's do this out, and then we have to tell bear is roaring. A bear is also roaring. Okay, or howling. Howl. Okay, now let's say howling. Oh, roaring is perfect. Now because there is one more that is public, void, and then moves. I guess most probably. It's a move or moves. It's a moves. Okay, so we have to do moves, and then we can say s out, and then bear up. Bear is walking. Perfect. Now this, with the help of this concept, we are able to achieve the concept of multiple inheritance as well. Now let's compile this program one more last time. Okay, perfect. Now let's run this. Why this? Why we? Okay, because we didn't create any object for that. So let's create the object for bear. Bear. Okay, bear real. Okay, let's bear equals to new bear, and then we have to call these things like bear dot make voice, and then we have to also call this function bear dot what is this, moves, I guess, moves. Okay, perfect. Now let's do this one more last time. Compile the program, run it. So now we can see like bear is roaring and bear is also walking. So this is the entire concept of like object-oriented programming. Hopefully you enjoy the lecture, and if there is anything I missed out or I'm not able to explain it properly, do let me know in the comment section, and see you.